Okay. So we wrapped up lesson 6 and 7 today, which honestly, they could have just been one lesson to begin with, because they both talked about equivalent equations. So lesson 7 specifically was thinking about why some steps for rewriting equations are valid, but other steps are not. So when you're rewriting equations, maybe you're manipulating it in some way, you're making equivalent equations. So that's why I'm saying like those could really be the same equation. Anyway, you have to be able to explain why some algebraic moves create equivalent equations and some do not. You will be directly tested on that on your constructed response. So you will have to say like in words why you can add 3 on both sides and it helps you solve or something like that, or why it makes an equivalent equation still. And then what doesn't make equivalent equations, what makes it look like it's no solution when it's not. So those are things we directly looked at today. You'll see it again on the practice test and hopefully you can execute those well. You have to be able to identify when it's no solution and what that means. So when I say solve an equation, what am I asking you to tell me? Find the value of the variable that makes it true. So when there's no solution, what does that mean? That there is no value for the variable that will ever make it true. So that's like having, for example, x plus 1 equals x plus 2. There is no value of x that will make that true, no matter what you do. You could try isolating it, like you could try moving the variables to one side by doing your inverse operations and stuff. But when you see that it ends up canceling out and you get something that is not true, that's a no solution situation. Okay. So now we're throwing that in the mix. One thing that I kind of wish I realized before is that some of you might not know how to solve equations when there's variables on both sides. So let's talk about that for a second. Let's give you some steps. Maybe you want to write them down. No. Let me do it different. So we already covered how to solve like 1 and 2 step equations. Here's how to solve multi-step equations. You might already know this and not need to take notes on it. To some of you, this might be like brand new information. Who knows? It was supposed to be taught to you before, but things don't always stick. So solving multi-step equations. First step would be to distribute if necessary. You guys know when to distribute? How do you know when to distribute? What should be there? Parentheses. And it should be, I'm going to make a random example. So this may or may not work out nice. And it should be that something on the outside is being multiplied by it. Okay, so I'm making a random problem. It may or may not have nice answers. We'll see. But if you see numbers in this setup where there's parentheses, something added or subtracted inside, you take the outside number and multiply it by both of the inside numbers. What's 3 times x? What is 3 times 2? And then everything else kind of just stays there, it doesn't go away. But all we did was distribute. You might not have to distribute in some of the problems. Sometimes there's no parentheses at all. But if there is a way to distribute, usually you do that first. You can't go wrong if you do it first. So distribute if necessary. Step 2 would be to combine like terms if necessary. So again, you might not have to do it every time, but you always check after distributing. So like, say I had some other stuff on the left side, like +7. then I would have to combine like terms, which my like terms would be the 7 and the 6. Right? Do that in that step. But check each side of your equal sign. Are there any like terms on this left side? Do we know what it means for it to be like terms or not? If it has the same variable to the same exponent. That kind of part you might not need to care about right now, but this has a variable, this one does not. These are not like terms. On the right side, are these like terms? They are not like terms. So I don't need to combine like terms in this one. I can move on to the next step, which is to move the variable to one side. Doesn't matter what side. It doesn't. What do I recommend you move? The smaller one, just because then it's less likely you have to worry about negative. So I'll decide to move the 3x. You can't just like pick it up and make it like 7x over here. Okay, you have to cancel it out on one side and then do the same for the other side. So how do I cancel out a 3x? All right, and whatever I do on one side of the equal sign. Notice I'm lining it up with its like term, otherwise you just have to know only combine like terms. But what's 4x minus 3x? And I have the -1 still, it's in here. And then usually at this step, it's a 2-step equation or a 1-step equation. But basically at this step, you just isolate the variable. Get it completely alone so that you know what it equals. So what's opposite of subtracting 1? Whatever you do on one side. So on this random problem I made, it happens to work out nicely. X equals 7. Okay, so in case you didn't know how to solve a multi-step equation, here's the step. You can come back to this video later if you need it. But distribute if necessary. Combine like terms if necessary. Move the variable to one side if necessary, because sometimes it's only on one side anyway. And then isolate the variable. Always do this order. Questions, comments, concerns? No, if I moved it, like, okay, so if it was this. And I subtracted 4x on each side. What's 3x minus 4x? Alright, so it becomes -1x plus 6 equals -1. It's just a little less easy to isolate, but it's still possible. So then you have to, it's just a 2-step equation. You'd still like subtract 6 on each side to isolate. Now -1x equals -7. Opposite of multiplying -1 is. And you still get the same answer so long as you follow like all the math rules about inverse operations and stuff. But it's just sometimes makes an extra step for you. So that's why I recommend you the smaller one, but if you do the other one, it should still work out. Okay, good question. Any other questions? So I'm gonna leave this up for a while, maybe let it marinate, maybe you want to take a picture of it, so you have it, I don't know. It is recording right now, so you can always look at it later. But, your to-do list is basically your lesson 6 practice, your lesson 7 practice, since we did both of those, we finished both of those today, 80% or higher on those. I'm gonna pass back your coloring activity, I'm gonna put in that grade 2 before I pass it back. And you can decide if you want to resubmit it for more. So that's up to you. There's no penalty for late work in here, but like if you didn't turn it in, it will be missing until you turned it in. And things like that. As always, let me know if you need help as well. Number 4. So again, if you don't need help with this one, please don't talk. So Kieran says that if x is a solution to x plus 4 equals 20, then x is also a solution to 5 times the sum of x plus 4 equals 100. Is Kieran correct or not, and why? So what you there's probably a few ways you could go about this, but. Figure out what X is, I think seems to be the easiest way for most of you. So like isolate X in this one, how would I get rid of this 4? And whatever you do on one side of the equal sign. And that gets me that X is 16. See if that works over here as well. And here you can distribute, or you can just do that same thing I told you, start with what's farther from the variable. So what's farther from the X, the 4 or the 5? The 5 technically. If that gets confusing, think of like order of operations in reverse. Normally you do parentheses very last or very first, like normal solving. When we're figuring out what X is, that's technically closer than the 5. That's outside the parentheses. Okay. So what's opposite of multiplying by 5? So I'm gonna divide each side by 5. That will just give me the X plus 4 in parentheses, so really technically the parentheses can go away. And what's 100 divided by 5? 100 divided by 5? 20. What's opposite of adding 4? And you can kind of see this was what the original equation was anyway. But you get the same X value. So he is correct in saying that if X is a solution to this one, it's also a solution to this one. And the difference between this one and that one is that they multiplied both sides by 5 in this one. Okay, so let's see which answer best says that. So I'm gonna cross out the ones that say he's incorrect, because they do have the same solution, so it is correct. First one says, because adding any number to both sides of an equation makes them stay equal. That's not what they did to get this equation. This one says, because multiplying both sides of an equation by the same number keeps the two sides equal. That one is the answer. Does that make sense? I know it's like making you think of it in a weird way, but if you can manipulate one to get the other, they are equivalent. So if I take my original and multiply both sides by 5, that gives me this one. Okay. Other questions of any practice, any worksheet, Amy?
Oh, lesson 5. What? No, not lesson 5. Question 5.
On the lesson 7 practice?
Mm-hmm.
Okay. So the Entrepreneurship Club is ordering potted plants for all 36 of its sponsors. One store charges $8.50 for each plant plus a delivery fee of $20. This equation represents the cost of ordering potted plants at a second store, so a different one. What does X represent in the situation? So they didn't make you this equation, nor do I think you really need it for answering this. But if they're charging $8.50 for each plant, what operation is implied right here? Multiplication, because it'd be $8.50 times however many plants you have. You could use P or whatever letter you want. Plus, so literally a plus sign, a delivery fee of $20. How many, how often are they including that $20 delivery fee? For every plant, right? At least that's what I'm thinking. No, because it kind of sounds like maybe they're delivering it to one person. I don't know, but I'm gonna go with that. It's just a one-time fee. That's what I think. Compare it to this other one that has it as X plus 750 times 36 equals 320. What do you think that X is in this situation? Compare it to the one that we set up. So in this one, the X is most likely the delivery fee because it looks like this $7.50 is my price per plant because they're multiplying it by a number. Right, and it said 36 sponsors, so I guess I would have done 850 times 36 over here. I didn't realize they gave me the value. All right, but yeah, so that seems legit. Let's see which one it is. And that's for the second store. This is my second store equation. So that is the best answer. Right, good. Any questions? Okay. Other question? Austin? On lesson 7? So the first one on lesson 7, if you're following along. We have this one where we're matching each equation with an equivalent equation. Some of the answer choices are not used. So in this one, I don't know if they all have the same answer or not, or if there's like differences of answers. So what I would go to is if you can manipulate one to get the other, then they are equivalent. So I would look at my options probably first and see, like, compare this one to this one. What's the difference between these two? Aiden? So the left side is different, the right side is not. Is there any math that I could do to this side that gives me 9x? No, because these are not like terms, you can't just like combine it. So I'm not gonna pick that one for this one. See if it could work for the next one. What's the difference between this one and that one? So just the left side. Is there any math I could do to this left side that gives me 9x? No, because even if I were to distribute, it gives me 3x plus 18, not 9x. So that one doesn't match that one. What I did just say matches this one. So I'm gonna connect that one to this one. Right, because when I distribute, I get 3x plus 18, the right side stays the same. Let's see if it matches this one. Is there any math I could do? First of all, there's lots of things different going on. Is there any math I could do to this one to get that one? So then this one doesn't match any of them. So don't match this one with any of them. But that's what I would do. I would try to see, I would go through my options first. Now for this one, 3x equals 4x plus 7. What's the difference between this one and the first one? The left side, what changed? And how would I make the 6 cancel? Whatever you do to one side. Now, that would make the 3x alone, but the right side would have to become 4x plus 1. So these two certainly don't match, so don't connect those two. Would it match the other one? This one? Is there any math I could do? Even if I move the 4x to the left side, I'd have to subtract it from the right side to make it move to the left side. So it would definitely not be positive when I do that. You have to do it yourself. So this one doesn't match any of them. The 3x minus 1 equals 4x. What's the difference between this one and the first one? What disappeared on the right side? How would I make this 7 disappear? And whatever you do on one side of the equal sign. So see if when I simplify it, do I get this? Yeah, the 6 minus 7 is -1, and then of course the 7 would be gone. So this one does match that one. And then we already ruled out the other two as belonging to any of them. So then this one must go with this one. But when you check it out, it does make sense. Like if you combine these like terms, 4x plus 3x is 7x. And if you combine these like terms, 7 minus 6. So for that one, I would write back. I would look at my options, see if I can manipulate any of the others. Questions on that one? Questions on others? Students? Number 6 on this practice. Okay. So I definitely shouldn't have any non-submissions for this practice. Everyone should always submit everything always once, given power. But this one. Which equation is equivalent to 5x plus 30 equals 45? In this one, there is just one x in each of them. You could solve them all and see which one has the same solution, and then that would be your answer. Up to you, whatever is easier. I kind of like the manipulating each side, but let's see. The difference between this one and my original, what changed on the left side? It became 35x. Am I allowed to combine these two together? No, because they're not like terms, so don't pick that option. Over here, it looks like the 30 went away on the left side. How would I cancel it from my original? What would I have to do? Subtract it. Sorry, it's lagging. And whatever you go on one side of the equal sign. So really, if I did that, it would be 5x equals 15, not 75. It looks like they accidentally added 30 on both sides, so don't do that. These are inverse operations. Over here, this looks like it could be maybe a precept to this. We'll see. When numbers are in this format, you do what? Which means taking the outside number, multiplying it by both inside. What's 5 times x? What's 5 times 30? $150. Definitely not 30, right? So don't be that. The process of elimination, it must be this one, and of course yours might be shuffled, so just blindly copy. But this one does make sense because when you do distribute, it does give you 5x plus 30 when you properly distribute and multiply the outside by both the inside, you do get the original. Okay. Good questions on that? So really, even though we did like these activities and are kind of thinking about it, I would say in a more like high level way. I think if you go back to these steps for solving multi-step equations, I think that would be what to do to be successful in this question. But we might have time for one more. Any other questions? Any So, yeah, if you want to resubmit that coloring activity for more points, make sure you do. I might not remind you every day. If you never turned it in, do turn it into that middle bin over there. And I will update that grade as soon as